Hello everyone, welcome to Physics Talk 4.4, Elastic Potential Energy Calculation. So this is part of Chapter 4, Section 3 in your textbook. So please take good notes and let's look at our lesson objective. So our learning objective is to use the elastic potential energy formula to calculate E elastic, spring constant, or the displacement. So as long as I give you 2 out of the 3, you should be able to find that third one as long as I give you 2 out of 3. So, using mathematical and computational thinking is our SEP again. Pattern, scale, proportion, and quantity is our CCCs. All right, let's look at the first example. So example 1, what is the elastic potential energy for a 2 kilogram mass attached to a spring with a spring constant K of 250 Newton per meter that is stretched to 5 meters? So, looking at the givens, we got 2 kilograms, which is the mass. We got the K already that's given, and then we're also given the 5 meters. So that's going to be our X. So when we look at the formula says, we're looking for elastic potential energy, which of course is EEL. So EEL is 1/2 kx squared. I have the K, which is right here. I have an X. And notice mass is not in this formula, so mass doesn't matter. So you can ignore that M on there. And we plug that in, we get 1/2, 250 for the K, 5 for the X, and it's squared. Order of operations, just like in kinetic energy, we got to do the square first. So that's going to be 250. And you can do half of 250, which is 125. And 5 squared is 25. Half of 250 is 125. And so when you plug that in, we get 3125 joules on our calculator. So now the question is, what happens when we double this distance? So now we're going to double the stretch. Same formula again. EEL is 1/2 kx squared. This time our K is still 250, but the distance is now 10 meters that we're going to plug in there. So when we plug that in, we get 1/2 250 times 10 squared. Again, we do the square first, which is 100 times basically half of 250, which is 125, and we get a number that is 12,500 joules. So in comparing these two, what does that look like when you double it? By what factor did it change when we double the stretch? Yep, when you divide those numbers, it looks like it's a factor of 4. And so 4 means quadrupled, which means, yeah, that makes sense. It's just like kinetic energy, right? So whenever we doubled the velocity in kinetic energy, it was quadrupled. So same with this one because it's being squared. When you double this, it's going to be quadrupled. If you triple, it's going to be 9 times greater. If it's 5 times greater, it's going to be 25 times. So whatever it is, it's going to be squared that number. So if it's double, 2 squared, 3 squared, 5 squared, whatever it is. All right, so example 2. This time we have 3,000 joules of energy is stored in a spring that has a spring constant of 100 Newton meters. By how much is the spring compressed? So when we look at this question, we know that we are given E elastic, and then we are also given the K value here. And this question of by how much is the spring compressed, we're actually looking for X. So that is our unknown. So when we do this, the elastic, of course, is 3,000. K is going to be 100. X is what we're looking for. When you plug those in, 3,000 times 100x. Order of operations says take care of these guys first. And so we get half of 100, which is 50. And so now what do we do to solve this? What should we do? Well, you're right. We got to divide both sides by 50. So we divide both sides by 50. And we get 60 on the left equals x squared. Just like in our kinetic energy, what do we do to both sides next? We take the square root, taking the square root, and we just round the answer to about 7.75 meters. And of course, the units of m is always going to be in meters, and that is our answer. So those are our examples for today. If you have any questions, of course, go to tutoring where we can help you out. You guys have a great day.